Hello, today I'm going to review a paper titled Modeling the Effect of Employee Injury Risk on Injury Productivity and Production Quality Using System Dynamics, written by Mashal Farid and Patrick Neumann. Motivation for the study is for the importance of product quality that is crucial for the competitiveness of manufacturing companies. There is a growing recognition that human factors significantly contribute to companies' quality performance. While human factor intervention can lead to improved quality, neglecting human factors in the design of work system can result in poor work environments and degraded quality. Previous studies have identified operator fatigue is a common issue linked to this quality deficit. Excluding human factors from work system design can lead to injuries for system operators. Work-related ill health carries significant costs comparable to those of all cancers combined, with musculoskeletal disorder being the most reported lost time claim. Employees with work-related injuries often perform below their optimal level, contributing to quality and productivity losses. Despite the evidence, human factor is often given little consideration by managers and is frequently ignored during the design stage. Manager may not be aware of the importance of human factors in achieving strategic goal and often view human factors solely as a safety issue. Consequently, human factors related issues are typically addressed reactively through problems and complaints rather than proactively during design phase. There is a need for tools and model to help system designers and managers understand the impact of human factors aspect on operational performance beyond health and safety. The current study explores the use of system dynamics modeling as a tool to support this understanding. The paper studies the use of system dynamics modeling to examine the impacts of human factors on worker injuries, productivity, and production quality. Its focus on low back pain injuries, a common issue in manufacturing environment. The underlying logic is that human factor in system design affect low back pain injury rates, which in turn affect productivity and quality performance. The study used SD modeling, which is distinct from other commonly modeling techniques like discrete event simulation and agent-based modeling. Unlike other modeling techniques, SD is particularly suited for understanding cause and effect and feedback relationship within the system. SD models are based on mental models of managers, providing a platform to test assumptions about the system and understand interaction between factors such as low back pain, injury risk, and performance. The causal loop diagram is developed into structural model. The model is divided into three sections. The first is human factors in the system, that describing low back pain risk factors and human effects and system effects, as can be seen over here. Then the researcher did the model testing. The model was run with two sets of inputs. The first set was the base case values, which represent the standard condition under which the model operates. The second set involved a sensitivity analysis. This approach was used to examine how changes in individual parameters affect the model's behavior. The simulation period for each run was simulated over a 5-year period. The duration was chosen to ensure that the model could reach a steady state or exhibit a trend, providing a comprehensive view of its long-term behavior. And then they are doing the phase validation to ensure the model's validity. Phase validation performed with two assembly plant managers. The testing methods were designed to evaluate the model's robustness and reliability in simulating the effect of employee injury risk on productivity and production quality. The results for the four main model parameters are shown: fraction reporting pain, human error probability, production rate, and rework rate. On fraction reporting pain, model showed that the percentage of operators reporting low back pain increased from approximately 0 to 1.3 over the 5-year simulation period. This is lower than prevalence reported in the literature, which ranges from 7 to 15%. On human error probability, the model indicates a 40% increase in human error probability over the simulation period. Production rate, there was a slight drop in the production rate by 0.2% over the 5 years period. On sensitivity analysis, we can see peak hand load, shift length, and spinal load while working result. So on the peak hand load and spinal load while working, we can see inverse relationship between presenteeism, working while in pain or injured, and yield rate. The results show an inverse relationship between while working in pain or injured and yield rate. And then on shift length impact, HEP increased by 0.04% slightly for every additional hour worked, and emphasizing the importance of managing work hours to maintain quality. Discussion point on implication. The paper suggested integrated approach to human factors and collaboration between disciplines, and also finding to improve system dynamics modeling and strategic design decision on human factors. And there are educational implications. The paper points out the lack of human factor aspect in some engineering education programs. Conclusion. The study demonstrates a novel application of SD modeling as a tool to help industry professionals understand the impact of human factors, risk factors on both the health of operators and the performance of manufacturing system. And quantification of risk factors. The model successfully quantifies the effect of low back pain risk factor on operator health, as well as on quality and productivity within a production system. These effects are shown to potentially intensify over time. And then simulation result. Over a 5-year simulation period, the percentage of operators reporting pain increased from approximately 0 to 1.3%. Human error probability increased by 40%, and the production rate dropped by slight only to 0.2%. Long-term impact on design decision. The study highlights a cautionary point for managers and designers, noting that poor design may not leave immediate impact, but can lead to quality problem over time. The sensitivity analysis revealed an inverse relationship between presenteeism and yield rate. And shift length is identified as a critical factor. Among the risk factor analyzed, shift length was identified as having the greatest effect on quality, with HEP increased by 0.04% for every additional hours work. Model feasibility and future work we'll discuss in the next slide. The limitation of the model only address a limited number of known injury of risk factor, and suggesting the actual impact on quality and productivity could be higher than indicated. Current model demonstrate the feasibility and modeling technique, though further development and detailed validation are needed. Further studies with different scenarios to include additional risk factor and injury categories may be feasible. Exploration of the broader impacts of human factor on quality and productivity. Finally, the presentation is concluded. Thank you for listening, and have a good day.